Question 1A. Without using tables or calculator, simplify this, leaving your answer in standard form, that is scientific notation. Solution: we have the given problem. In order to show that calculator or tables, none is involved, you have to work it out manually by converting the decimal numbers to whole number. If you convert this to whole number by moving the point forward, you have to multiply it by 10 to the power of minus 1. That is what you have here. You are converting it to whole number form. If you move the point forward, you multiply it by 10. Because the movement is done once, the power is minus 1. If you are moving forward, the power is negative. If you are moving backward, the power is positive. If you do the same thing here, you have this result. If you do the same thing in the denominator, you have this followed by this and followed by this. Alright, now let us bring all the whole numbers together and base 10 together. That is what you have here, so that you can reduce effectively. Before that, this can cancel this, this we cancel this, you are left with this. Okay, now let's come here. You divide 32 by 16, you are left with 2 here. This 2 that is remaining here times 6 is 12. That will remove this 12. You see that? You have 4 and 8. If you reduce, you have 1 over 2 times 10 to the power of minus 2. If you take this 10 from denominator to numerator, the power changes to positive. So 1 over 2 is the same as 0.5 times 10 to the power of 2. Now in standard form, the point always comes after the first non-zero number, after it, not before. So the point should leave where it is to after 5. That should be 5.0, the same thing as 5. The point moved once, you multiply it by 10 to the power of minus 1 before this 1. So you have 5 times. You apply multiplication law of indices, you have to add the powers. Minus 1 plus 2 is 1. So you have 5 times 10 to the power of 1. Question 1B. In the diagram, EF is parallel to GH. If angle AEF is 3x degrees, angle ABC 120 degrees, and angle CHG 7s degrees. Find the value of angle GHB. That is this angle only. So to get that angle, diagram is adjusted to this form. So let's see how the adjusted diagram will enable us to find the value of angle GHB. So you have the same diagram. Now this angle will help us to find the required angle. Before that, this angle here, if you add it to 7s degrees, the sum is equal to 180 straight line angles. That is what you have here, and that is this. So if you make GHB the subject, you have 180 minus 7s all in degree. So all we just need is s for us to get angle GHB. Because MN is parallel to GH, this angle here is also equal to GHB. That is, GHB is equal to HBN. That is 180 minus 7s, or in degrees alternate angles. Now this small angle here, this angle to here is 3s degrees corresponding angles. Now you know this angle and you know this angle. The whole of the angle is 120 degrees. So if you add the two sub angles, you equate it to ABC as given to you. That is this plus this equal to 120 degrees. If you open the bracket, you have this. Now this is 180. If you move this one in, it becomes minus 7s plus 3s is minus 4s. If you take it to the right hand side, it becomes 4s. So you have 60 degrees equal to 4s. Divide through by 4, s is equal to 15 degrees. Hence, angle GHB is 180 degrees minus 7s degrees, and s is 15 degrees. So you multiply it by 7, that is 105 degrees. Subtract it from 180 degrees, that gives 75 degrees as the value of angle GHB.